Systems as our Director of Wind Sales. So that's Remi. And here we also have Rich. Rich is the president of MRG Labs. He has 25 years of experience in the development of condition-based maintenance programs. He also has technical presentations at the American Wind Energy Association and Wind Energy Update conferences. He has served on 2 research teams in Denmark, studying lubrication and sampling practices for offshore wind turbines and wind turbine components. He also worked alongside employees of Baden Falls and Dong Energy. So now I present to you grease sampling analysis for wind turbines with Rich and Remi.
Thanks, Marissa. And I'll just do one more sound check here. Does this sound good?
Can hear you loud and clear, Rich.
Okay, great.
Yeah, I can hear you as well.
Super. Remi, thanks for joining us. We're just going to give a little bit of background on how we get to this point and really ask that first question. Why would we sample and analyze greases from wind turbines? So there's a few things to consider here. One is that, before we even start to talk about the condition of the machinery, which is what we often focus in on when we're sampling and analyzing greases, it's just about consider the grease itself, because not all new greases are clean. And we kind of know that, or we should know that about oils, and that's why we often filter oils before we put them into the machinery. But you can't really filter new greases once you've purchased them, once they've been formulated and blended together. There's no real good way to filter them for moisture and particulate. So the initial cleanliness of the grease that you purchase, what's in your grease gun, what's in your auto luber system, is really important and directly affects the life of the components. And then we look at the in-service equipment. For the in-service greases, the warning signs of issues related to both grease condition and the condition of the asset are there prior to failure, and we can take actions to mitigate the damage, to minimize what happens if we find this early through monitoring. And then we can also go beyond and identify those systemic causes that might be affecting not only the particular asset we're looking at one point in time, but by going to the root cause of damage, of accelerated wear, of degraded grease, of even failure, we may be able to find these root causes and then correct them across our program, across our maintenance functionality, to have an impact on many components. So sampling methods are out there. Sampling methods have been developed over the last 10 years for greases, and a lot of this is captured in an ASTM standard, the American Society of Testing and Materials. And that's ASTM D7718. It's been proven in wind applications through testing. Marissa introduced me and as having been involved in some research projects in Denmark over the years to kind of validate this approach to sampling. And a lot of this has also been captured as best practices in the AWEA, the American Wind Energy Association, RP, the 800 series for recommended practice guidelines. There's also analysis that's defined in an ASTM standard. That's D7918. And that's also been proven through the same kind of research and the test selection guidance that we find in a specific standard for grease analysis for wind turbines, and that's AWEA RP 815. So it's been developed, it's been evaluated, it's been tested through R&D, and now there are standards around taking samples and analyzing greases from wind turbine components. We know that contamination or compromised lubricant, either the wrong lubricant, mixed lubricants, lubricants that have degraded, can be traced to the source. How did this happen? Why did it happen? Use that to prevent systemic failures. Our wear levels can be compared to similar equipment. This really works out well for wind turbines, where you typically have a farm with a distribution of very similarly designed, often the same OEM, under the same kind of environmental conditions and fairly similar operating histories that includes the rate of grease replenishment. And so we can put them and group them together and trend them with routine sampling. And then there's some new tools available that we'll talk about today to support even smaller drain sizes or different blade bearing applications. What about the value of grease analysis? Because that's often the question: how much is this going to cost me, and is it worth it? Is grease analysis worth it? Well, the screening analysis that I'll talk about here could be done in an entire wind turbine. I'm talking about all the components, all the grease lubricated components, from the blade bearings, main bearings, generator bearings, and even the yaw, for less than 400 hours a year. Some problems can be corrected uptower to save money. And so, Remi, you come with a strong background in the wind industry. Can you talk about that a little bit?
Yeah, I mean, for sure, through condition monitoring and grease and oil analysis, you can certainly pinpoint issues to where you can take a more proactive approach, do less expensive uptower repairs in order to mitigate your chances of catastrophic failure on some of these components. Speaking specifically about the grease lubricated components, such as the main bearing, there's things you can do like hot oil flushes periodically in order to purge some of that material, that ferrous material, out of the bearing to prolong the life. There's plenty of other mitigation techniques as well.
Yeah, and you and I have talked about, for instance, with a hot oil flush or something like that someone might want to do. The question becomes, when do I do it? When is it time to do that? And if we can monitor the condition of the grease, we might be able to create numerical criteria for that, right?
Right. And oftentimes, through grease analysis, you're going to get an early indication of whether or not you're going to need to perform something like a hot oil flush. Vibration, condition monitoring, it does detect main bearing issues, but oftentimes it's a little too late in order to take as proactive of a measure like a hot oil flush on a main bearing.
Right, because at that point you've already got some physical, mechanical damage to the surfaces before it's going to show up as vibration.
Yeah, you have asperities, indentations on rollers, races, outer races, inner, and that stuff. You're generating more and more wear debris as that continues on. So the key is to get ahead of that.
Right. And then, of course, after you do something like that, like some sort of flush, you could be pulling a sample and looking at that just to validate whether that was successful, or even maybe use it to determine when you're done, right?
Yeah, and I think there's owner operators out there that do take those proactive measures. There's others that don't, and they wait until these components are near failure and just end up replacing them. So if you are considering doing something like these proactive hot oil flushes, taking grease samples before and after and throughout, after you've done this, can help validate whether or not you are protecting, getting more remaining useful life out of that component. And that's the end goal.
Sure. I remember when I first started with one years ago with one wind turbine operator, we took the very first samples on that wind farm, and I said, hey, here's one tower that looks like it's in distress. I remember them saying, I wish we knew this 3 months ago, because we had just had a crane out to the site repairing something else, and it would have been nice to group those tasks together. That's another benefit from monitoring and knowing what the overall status of a wind farm is, right?
Certainly. And to your next point on this slide, a single failure can be upwards of $350,000 between downtime, crane rental, and the component itself. So, and those prices are really, they're being driven down by competition, but they're also being driven up by larger and larger components. We're seeing land-based turbines that are 2, 3, even 4 megawatt class now, and they're becoming more and more populous throughout the U.S. and beyond. So it's important to be able to look at your fleet as a whole and determine, which components in which turbines do I need to prioritize this year, and which ones do I need to look beyond to next year?
Yeah, and then of course in the U.S. we have the coming promise of the offshore wind industry, right? That's where we're going to see a big build out in the coming years. When we started working in Denmark, a lot of that was for offshore wind assets. And I remember hearing when we had identified a bad bearing, the answer was we didn't even have a ship to go out available to do the maintenance for the offshore equipment, and it had to be delayed as a result. So that's where these things can really be important from a scheduling and planning standpoint.
Right. And, again, the costs for offshore maintenance are much higher than for onshore because of multiple factors. So, having your technicians, the time that they're spending in the towers, ensuring that they're, taking grease samples and that stuff and those are being analyzed properly and sent to labs or screened on site is very important.
Right. So yeah, it's about efficiency in a way. And that's what we can do with grease analysis. We can use the feedback from the results to help optimize lubricant use, like how often should grease be added, or how much should be added, or if it's an auto luber system, how should we dial that in and tune that to get the most out of that, just to optimize the delivery rates, things like that. And then, like you say, when the maintenance folks are out there, that's when we want to schedule the sampling, right? So we're already up tower, and really the differential cost to grab samples is not that great once you're already on site. So we've tried to make the tools very versatile, very accessible, and very easy to carry along on an up tower job. And then that way, when some replacements are needed, other issues can be addressed at the same time. If we have gearbox issues, we can know, hey, is there also something on those blade bearings or something like that? Yeah, so about the standard development that I've talked about, really goes to addressing that grease is quite different than oil. And unfortunately, historically, sometimes grease just gets treated as if it's just a thicker oil or something like that. All we got to do is grab it and then hand it to an oil lab and tell them to do whatever they need to do to get some results to us. But grease is not the same. In fact, we describe it as non-Newtonian, which describes its flow behavior. We can't just suck it out. We can put a vacuum or a suction or some kind of pump to pull oil into a sample bottle, but that doesn't work with grease because of its behavior. We actually have to core the sample, much like taking a solid sample, because grease really is a semi-solid. So like a soil sampling or something like that, core sampling is really what we address with these sampling methods. So a lot of this research that came to these findings for grease sampling came about through this offshore wind research, the research done by the Electric Power Research Institute. And so this standard really builds that in and gives us instructions to sample from different kinds of components. And then you find that in these AWEA standards. There's 3 of them. AWEA has recommended practice guidelines for main bearing sampling, blade bearing sampling, and generator. So if you're a member of AWEA, you can go right into the site, log in, and request these documents, and they can be a really strong start to building a grease sampling program. A lot of it is built around, just sound methods and considerations on getting a good sample, like where is the sample really in a live zone? Where is it representative of what's going on? And sometimes to get to that point, to get past the grease that's not representative and get to that location, it requires some specially designed tools. So we're showing here some of what the Grease Thief looks like, the different styles that are there, and as well as this T-handle design that was really designed for main bearings in Denmark. We were in Denmark and we had kind of a prototype. It wasn't quite right. It didn't give us the ability to reach as far as we needed to go, or really to precisely vary the depth that we take that sample, trying to get it right at the face of the rolling elements. And so as a result, we developed this device, this T-handle device, that mates with the Grease Thief sampler that you see here. And it turned out to be a really good fit for sampling from the generator drain chutes as well. So main bearing grease sampling, the grease flow within the housing is dependent on the temperature and then the movement of the bearing, and also the flow characteristics of the grease. And so the Grease Thief sampler as well as the T-handle are used to capture that live zone grease. And you can see at the lower left, this is a picture I took in Denmark of one of the Danish engineers pulling a sample with a kind of a tiny prototype that we had at the time. Our learning there helped us design this T-handle that I just showed you. And then other, here's another style, very similar. There's a Grease Thief under all that grease there at the end of in this case, a metal extension handle, with the idea that that could go right into that access plug opening that you see there, go right to the depth that's needed, and then pull a sample that's representative. And then we talked about blade bearings and generator bearings and yaw bearings and gears as well. Now, not every time do you have that access plug. So in the middle there, you can see us taking a sample from just an enclosed bearing from the purge point where it's purging out through the shields that are part of the design of that bearing. We just consulted with a wind turbine operator with that style. We were talking about the challenge of getting the grease that lies underneath and not the grease that's kind of been exposed for some period of time. And in that particular design, there are some copper brushes right in the area. So you end up with a lot of copper dust, copper particles landing on that surface. So it's really tricky to get that grease that's underneath there that is representative of what's inside the housing, because that's what we really want to analyze when it comes to grease analysis. But we've really boiled it down to try to get the costs manageable for this initiative, because if you have a major concern, or you want to target a particular wind turbine, or maybe you're at end of warranty work, you might say, I'm going to spend X amount of dollars and figure all that out. But in terms of routine monitoring of these assets, a lot of times people walk away from that because they say it's just too expensive to justify. So we've looked at the data over 10 years and said, what are the key parameters that are indicative of changing conditions? In other words, how can we screen samples with a low-cost test slate, and then know which ones we need to go further, and as a result, have an overall lower cost of incorporating grease analysis into the monitoring strategies for wind turbines. And we come to these two key parameters, and one is the ferrous content. So we can boil all this down from a wear perspective to the ferrous or the iron containing content that we find in the grease. And if we can accurately and reliably measure that, regardless of how big the particles are or how evenly distributed they are in the grease sample that we take, then this becomes a value that we can screen reliably and say, this is normal, this is expected, or here is a bearing that needs a second look. Here's a bearing that has a higher than expected wear rate, and we can define exactly what's going on by some follow-up testing. So this low-cost screening is using this device, the FerroQ. And it's great to have Remi with us today, because we reached out to Poseidon knowing their experience with ferrous detection technology sensors in their line of products that they have for the gearbox oils in many wind turbine applications, and said, can we take that technology and adjust it, adapt it so that it's going to work for discrete grease samples? And the result is the FerroQ. We'll show you that in a minute, talk about that a little more. The other complementary test that we have is something that we developed here, which is the Grease Thief Colorimeter. And that's something that looks at the optical properties of the grease. And a lot of these greases start out with a dye. They're dyed so that they look blue or green or yellow or red or whatever that manufacturer decides. But there's a lot of information in that. And if you can carefully control the space, the path length, it really goes to something called the Beer-Lambert law, where we can look and determine changes in the grease, things that get into the grease from a contamination standpoint, as well as the oxidation that results in a chemical change in the grease, and that can be linked to changes in its colorimetric spectral response. So that two-part test between the FerroQ and the Grease Thief Colorimeter can test the grease conditions and the bearing wear in under 5 minutes, and it can be done on site, and that's what we'll share with you here in a minute. Now, sometimes you look at that and say, okay, now I've screened that out. I've looked at 100 samples, but here's 5 that are the ones that need further attention. Well, that can then also have some further analysis done with it. Or if we're not doing it on site, we could take this sample and then send that off to a laboratory. And typically that's going to be under $30 per sample, including the sampling supplies themselves. So, you know, that's what we're achieving here with this low-cost screening. In this scatter chart that you see here, we've created it's actually quite a variation in ferrous content over a population of a couple hundred wind turbines. And we've grouped them together and put them on this scale, which is a logarithmic scale, or mostly a logarithmic scale. And you can see that, you know, some of these are grouped together. They're fairly low, around 100 or a couple hundred parts per million ferrous content, but others you know, have much higher rates, and that could be related to maintenance practices. It could be related to known design issues with some of those bearings. It could be related to the grease itself. And so we can get a handle on where our assets relative to each other, relative to our fleet, and kind of pinpoint those areas that we need further attention. So the sampling kits that we use, you can see here, and I'll display these in a moment, kind of demonstrate this, but you can see this is our wind kit, and it has 8 different sleeves in here, which pretty much is enough samples to go from one end of the wind turbine to the other: blade bearings, main bearings, generator bearings, and even grab a yaw gear grease sample as well. And then be able to take that and either turn it right around and ship it off for analysis, or use this mini lab solution that we're talking about today to do it on site, even do it up tower to get those immediate results. So let's start with the FerroQ. Remi, you want to walk us through this one? This is your product, and yeah, tell us a little bit about it.
Yeah, I mean, this is something that we're very excited to get out into the wind industry, on wind farms. Of all the industries, I think it's going to be utilized very well on wind farms. So, I mean, essentially what this is, it's a portable benchtop ferrous wear analyzer. Uses similar inductive coil technology as our online oil debris sensors at Poseidon. You know, the purpose of this tool is to enable wind site owner operators to be able to screen their grease samples at site, and that can be, you know, the FerroQ is able to be brought up tower if that's necessary, or it can be kind of the centralized station at the O&M building for when technicians get back from their maintenances. It's as easy as, you know, dropping the sampling in and reading the readout. So, you know, rather than sending every sample to the lab, these can be screened. If they have high ferrous content, it can be sent out to the lab in order to get, you know, other properties. So, you know, ferrous content is really, you know, the best indication for the overall health of the component. The other properties that are measured in a typical lab test are, among other things, great indication for the lubricant health in itself. So, you know, focusing on that, the ferrous content gives us a good indication of the component health.
Yeah,
so,
and you know,
yeah.
you have there that you know, you've got that measuring capability up to 200,000, and you know, for those of us who've done a lot of oil analysis, that sounds like a crazy number. And when we first started doing this, we used some other devices that had a limitation of about 1/10 of that scale, and we saw ourselves going off scale, like quite often, especially on the blade bearings. And so I just want to point out that this is a significant enhancement. In fact, when we went to you guys, we said, hey, we need to get that upper scale because it's just too much. It's like what good is it if you run a whole bunch of samples and everything says off scale? It doesn't tell you a whole lot to differentiate between them.
Yeah, I mean, I think you pointed this out in the call earlier, the differences between oil and grease. In most oil applications, you're going to have a filter that's continually filtering out that ferrous content. In grease, you're not going to, there is no filter. Sure, the grease gets purged from most of the machinery that we're taking these samples from, but that ferrous content is still there and continually being generated. So it's very much a cumulative measurement rather than a concentration in real time. So, having that 200,000 ppm range is really advantageous on these wind turbines.
Yeah, and we've also seen other performance improvements from other ways of measuring ferrous content. One is the real small relative standard deviation that we've seen on this device versus some other devices. And I also want to point out that one of the real challenges for grease analysis is about the distribution of the particulate, that it's really what we would describe as heterogeneous in grease. Like when we take an oil sample, we shake the daylights out of it and get it evenly distributed and then take the sample, but you can't do that with grease. And I've seen the effect of a bias reading from other devices that don't have that uniform measurement throughout the range of the sample that you're submitting. And it was great to see that performance out of the FerroQ.
Yeah, and I mean it is very important that we keep this relative standard deviation very small at 2%. So essentially, if you take the same grease sample and drop it into the FerroQ 100 different times, every result is going to be within 2% of the mean reported value. So sorry, go ahead, Rich.
No, I'm just saying it is real helpful, and it's a few seconds to do this test. It's like less than 5 seconds to get a result. Yeah.
Yep.
Yeah,
it's very helpful to be able to, and I think that's something to point out here is I think it's really it's not necessarily something you can put a value on per se, but allowing the technicians and the site personnel to be able to do this, I think they're going to start taking more pride and everything in doing this from start to finish, taking the sample, testing it themselves, and recording all of that stuff. So, this stuff generally switches hands a couple times, but this is a simple way to do it, and you get instantaneous results.
Yeah, you and I didn't talk about this, but as you say it that way, I'm thinking back to my time in nuclear power, where we very early on, like in the late 1980s and early 90s, started adopting a lot of diagnostic technologies. And I remember asking one of my colleagues who was a machinist, a craftsman, and I said, which of these technologies do you think made the biggest difference in the condition of our assets? And he said he thought it was laser alignment. And he said, not because it's that much better than any other technology. He said, but it gives the guys in the field who are doing the maintenance immediate feedback on the quality of their work. And he says it's created this competitive environment where guys are coming back to the shop bragging how well aligned they got the equipment and sharing the results of that testing. And I could see the same thing happening here, whether it's a grease flush or a replacement was made or whatever, that you'll have that instant feedback to say, look, I'm happy, I'm leaving this wind turbine in great shape and it's going to run for a long period of time without a problem.
Yeah, definitely. I mean, I think that's something that we're going to come across more and more, where as we get these on more wind sites, it's just going to be a good, before it's, the technician takes the sample and maybe they're not even the one that ever sees the result. It'll be the site manager or the engineering team. So, having the ability to see that and track it every day is going to kind of breed accountability and get everybody to take more interest.
And like you say, pride in your work, which is great.
Yeah, that's right. So a little more about the FerroQ. This is designed very much with, working with the Grease Thief in mind. So once that sample is taken, it can be dropped or placed into that position that you see on the screen. And then within a few seconds, you'll get a ppm readout. Again, it's an inductive coil technology that helps us to be able to read this out with the accuracy that we do. And that's an LCD touchscreen display. And some of the functionality of this is pretty important for the guys on site. So we do have Bluetooth capabilities built into this, so that sites can have back-end software that collects that data. And a more simple way is just with the USB and a laptop, exporting it as a CSV file. So you're able to, at the end of the day, if you've got 4 different sites or 4 different crews that were doing maintenances on towers, that's quite a few samples to get through. So, I mean, it can be one after the other, reading out and recorded into the laptop.
And then
able to work with Poseidon Live.
Yeah. That's what I was going to ask you about with Poseidon Live. So this would be for, and by the way, give me a feel for, maybe not everybody knows, a lot of folks are familiar with Poseidon, but give me a sense of how many of these Poseidon sensor systems are out there.
So our in wind, our primary product is our online oil debris monitoring equipment. We call it our DM 4500 debris monitor. So there's about 7,000 of those out, primarily in North America, but we've got some international customers as well. This is a great form of condition monitoring. It's oil-based. We're able to see wear debris data in real time. We're able to detect the difference between ferrous and non-ferrous material and the size of those particles, so that we can put those into bins. It actually gives us in our opinion, it's the greatest way to indicate the health of the overall gearbox. So, as opposed to vibration, you are able to look at individual bearings or individual gear positions, but this is a great, if you've got these Poseidon sensors deployed across your site, it's super simple data to read, and you immediately know which gearboxes are the bad actors. So this Poseidon Live platform, we've got all this data streaming in there from the wear debris monitors. And if the sites that have those are also doing this stuff for grease sampling and screening them on site with the FerroQ, that can easily be integrated into Poseidon Live for main bearings, generators, and blade bearings.
So it sounds like a great opportunity for those who already have the sensors from Poseidon, or who are considering adding them, right, going forward, because now you've got an option to address not only the gearbox, but also the rest of the drivetrain by bringing the grease results into the same data stream.
Yep, for sure. I mean, it encompasses the full drivetrain.
Yeah, because obviously historically the gearboxes have been an area of concern from a reliability perspective, but you could have a perfectly working gearbox and have a blade problem or a generator bearing problem. And this gives you end-to-end drivetrain monitoring capability with one data stream, which is pretty exciting.
Well, and that's another thing I want to bring up too is, sometimes this stuff happens after the short OEM warranty period where you'll have, all of a sudden you're recognizing, wow, I have a massive blade bearing failure problem across my entire site. There's and we haven't been taking samples regularly, or we've got spotty data. When that problem's recognized, this is a great tool to say, all right, let's have this on site, do a complete sweep, do a couple towers a day, figure out what's going on, which turbines we need to focus on, and so yeah, it's kind of a quick response tool as well.
Yeah, for sure. Well, let's that's great. Thanks, Remi. I want to take some time to show some other things too, including the colorimeter, which is the other half of this mini lab solution. And it may not be as obvious or intuitive of what we're seeing here, but the way it works is it detects the darkening or changes in color, which could be from aging and oxidation. It can find evidence of grease mixing, which happens from time to time, and it's not good. It can have some very negative effects on the behavior of the grease, and then subsequently the performance of the bearings. Then we can also see accumulation of particulates and contaminants. It works with light and dark greases, and it takes less than 30 seconds per analysis to do it. And the way it works with the light and the dark greases is that it has multiple spacer configurations, which allows you to take a light colored grease and a fairly thick film of that and evaluate the color. And then when you get the dark grease, to take that down to a much thinner squeeze, if you will, for the spectrometer to see what's going on. And the result is that you can save these scans. You save the scans in a color representation scale, which is your CIE values. And those CIE values get related back to what does my grease look like right out of the tube. And so you can see a minor change here where the left side, this little kind of diamond shape, the left side of it is showing what the grease looks like new going into the machine. The right side of it shows it, after some period of time. The tower climb comes up, the sample is taken with the kits, and you can see there's a very small minor change in color. That's grease that's still in great shape, versus what you have on the lower right, which is that severe oxidation, and you get that specific path length color variation relative to the new grease, and you get values. You see these delta E values, 6.1, something less than 10 would be considered, over a period of time quite good, but this one's up at 44. And you might have the ability then to create some criteria. What do I do when I see this? And it goes again to the whole idea of, on site, on time, just in time, or, kind of a lab in the sky, if you will, that you could imagine where you're up tower, you're checking the ferrous content, you're looking at the color, and if you get some real negative indications, it may be time to do a flush right there. And you would have the ability to do it then, not have to make a bonus climb weeks later. And Remi, you've been up a lot more towers than me, but even the handful that I've been up on, I would want to limit my number of climbs if I could in any way. So having the data in real time can be very valuable.
Definitely.
And so here's some data to share that we've seen from the screening results. And you can see some values here from wind turbines. You got them numbered there. This is a number of them from a fairly large wind farm. And you can see, and again, this is kind of a logarithmic scale with some differences in values there. But you've got like some criteria. You got green, yellow, and red zones for this. And you can see that in this population, most of the ferrous content for these wind turbines was good and was under 1,000 or so. You had one that was in a few thousand ppm, and then you had two turbines that were really high, over 50,000 ppm. So they're real outliers, and it becomes very clear where our attention should be, which assets need our focus. And maybe a follow-up, maybe even, borescope is very popular in the wind industry, just as getting eyes on the condition of the assets. Well, how do I know which one to borescope? Do I want to do them all? Well, if I can narrow it down to 2 or 3, saves a lot of time. I know what needs my attention, and I can use my resources appropriately. Same kind of data coming from a colorimeter can help us make that similar. And here we got it lining up pretty good, but it lets us see that there might be a relationship here, that the wear levels that we see may be related to the color changes of the grease and vice versa. Not always, but sometimes they do support each other. Sometimes they're looking at different parameters, but together we see that whole picture. So, 3 of these samples need further analysis. The other 19 wind turbines in this case look good. Keep it on the maintenance schedule, button them up and move on to the next, but focus in on the ones that need our further attention. That's going to save a lot of time and money. So what we're doing with this is that we want to, number one, get a good sample, and that's getting grease in the live zone, using the Grease Thief, and using the kits that are out there that specifically target the sampling challenge. Use that in-service grease analysis, have that complement other condition monitoring systems like your vibration analysis. But like Remi said, sometimes vibration analysis lags a little bit some of the things that grease analysis may pick up early. So together they can be very helpful. And then getting the early conditions in the field, and maybe being there and doing some things in real time before we walk away and wait weeks for samples to come back. And I think that's really the power of the mini lab. So at this point, I want to kind of pivot. It's asking for questions, but I'm going to drop out of this shared screen, and I've got a kit right here in front of me, and I'm going to turn the camera around. And let's see, still says I'm sharing my screen, so let's see if I can get rid of that. Okay, and then if we can, I want to try to optimize this one window where I'm displaying, and I'm not really sure how to do that. Off here, nope. Marissa, can you? Do you have in your view a shot of the my display of the kit here? Is that optimized? How do we do that?
If everyone clicks on the picture in their bottom right, you'll be able to make it big. You'll be able to pin it to the screen.
I guess I can't do it because it's my own video. Maybe that's the issue. And maybe if Remi turns his video off for now, that might help me see a bigger screen too.
Rich, you're not able to turn off your screen share at all, are you?
I believe I did. It had a button that said turn that off.
Oh, there you go. Now you stop. Now we're cooking.
Okay, so now if you turn your camera and microphone off, then I think it should be the only feed, right? Okay. Well, let's get in here and see what we got. So opening up the kit, and notice it's one of these nice Pelican cases, and we've got everything in here. So you could imagine you have this buttoned up, you put it in your bag or your box you're setting up tower, if that's the case, or like Remi said, maybe it's just at ground level, but you get everything together here. So what do we have? Well, we've got a Grease Thief sampling kit, that has in here, it's going to have your sampling instructions to tell you how to use it. It's going to have these 8 sleeves that I talked about inside. You're going to have different tools. You've got a Grease Thief. You might have a label, a little container to ship it back to the laboratory if you need that. Even a return envelope is here to be able to send that back to the laboratory if you're going to need that further analysis. But we're going to focus on it today as if we're just going to take a sample and do that right on site. So when you open up the package, and we've talked about sampling before, so I won't go into that today as we get towards the end of our time period here. But again, you'll end up with a sample out of this. And so I'll just grab one here that we'll use for the purposes of our analysis. Now, what do we have? Well, we've got some tools here. We've got, this is going to be the iPad. I'm not going to use it for this demonstration, but the iPad has some software loaded on here that allows us to do the colorimetry measurement and save our data. We then have some other supplies here, like for instance, this here from a color perspective is going to allow us to take and fill these small liquid cells, and we could do oil analysis at the same time. So we could establish what the hydraulic fluid, the gearbox oil should look like and so forth, and do kind of an on-the-fly color test of those as well, maybe even some coolants or something like that. But we're going to focus right now on grease analysis. So right here is the spectrometer. This is the tool we're going to use. Very robust, but very powerful tool in terms of being able to make a reliable and scientific measurement. And so we've got that here to be able to do that. And then inside here is the FerroQ. So you saw this on our display and on our presentation. And this is the sample opening, and this is where we're going to put the Grease Thief. So when I take my sample, of course, you're going to get this plugged in or use some battery source that you have for that 12-volt DC, but it's just a matter of dropping that right into that opening. Now, there can be some variation from technician to technician. Maybe you put it in there kind of lazy, or you push it in hard, and maybe that varies it a little bit. So we've even come up with a way of trying to, or really effectively reducing that variation with this drop tube. And by putting that on top of this, you just have the ability to produce it in the same way every time. Really increases that repeatability down to that 2% that Remi talked about. So that's as simple as it is to set it up, get it plugged in, go to the screen, drop it. In less than 5 seconds, you've got a result, and it reads out on the screen. And as Remi said, if you've got Poseidon systems there, you can put it right into your Poseidon Live. Also in here, we've got the colorimetry capability. So you've got your charger there for your iPad, and then the key tool here is the colorimeter. So I'll close this back up. And here's our colorimeter. And what you're going to end up doing here is you've got a flat panel adapter. That flat panel goes onto the spectrometer. The spectrometer, by the way, is also DC battery operated. So you've got the ability to kind of pre-charge that and then be able to use that remotely. And then you have your spacers, and you'll take there's a bit of a setup here when you get started. This one's new right out of the box. So we go through that setup process. But there's my zero spacer, and that's going to allow me to set this up so that when I use the other 3 spacers that are here, I can do that kind of thick film arrangement that I talked about, or narrowing it down for the darker greases by changing the spacers. But here's the space where the grease is going to go, and that could be as simple as taking the Grease Thief that you have and removing that yellow cap and just dabbing a little bit right there and being able to adjust that down and take my measurement. So that's my colorimetry. Again, about a 30-second process. Note too that between those 2 tests, I've used almost none of my grease sample, meaning that I can do this in the field. I can put this back into my tube for shipping, and I can, if I see a problem, I can send that on to the laboratory and still get a full grease analysis from that sample that I took. So it's, again, valuing the time of people in the field, knowing how much effort it is to get to the asset in the case of a wind turbine, and having the flexibility to do the in-field testing, as well as having sample to send off for detailed analysis as well. So I wanted to share that with you. Fairly simple setup at ground level, back at the main building, out into the van that's going around the site, or even up tower if we want that immediate result, immediate turnaround to make a decision or get feedback on the suitability of some maintenance process that we're performing there. And so that's what we wanted to share with you today. Remi, did you want to add anything here to what we've talked about today?
No, I don't really have anything more to add, Rich, but thank you very much for having me on. It was a pleasure.
Great. So, Marissa, did you see anybody come in with any questions during our presentation today?
Some questions. Remi did answer the one. But if there's any questions right now, feel free to put them in the group chat. There is one, Rich, and it says, for FerroQ, how is it calibrated? Are the results consistent or correlated with other tests like ICP or DR ferrography?
Okay, great question from Bobby on that. So the calibration with this, there is kind of an initial factory calibration. It uses ferrous, small ferrous beads of known diameter, known volume, and content. It's used to calibrate it. We also create Grease Thief standards for this. So we basically have a distribution of ferrous content in a Grease Thief that's in a solid matrix. And then you can use that to check the output of the device to verify that it's giving that equivalence in ferrous content. Now, it's, in terms of the consistency is, yes, it's like Remi said, less than 2% of measured value, which is great for that relative standard deviation. And more of that data is going to be available, Bobby, as we go through an ASTM interlaboratory study right now, an ILS study, where we've got, I guess, about 8 of these units out there that are being tested by participating laboratories that'll report those results to ASTM. And so we'll really be able to see the repeatability and reproducibility statistics on this method. As far as correlating to other methods like ICP and DR ferrography, ICP has a particle size limitation. So you will get an elemental iron result from ICP, but it's going to be limited only to the dissolved or very small particles, maybe less than 4 to 5 micron. Why that's a little bit of a challenge when it comes to wind turbines, especially in the blade bearings, is they generate really large wear particles on the order of 50 microns, 100 microns, even several hundred microns from time to time. And we may think, well, that's in the very latest death throes, and that's not necessarily the case. From the studies that I talked about in Denmark, a very small amount of very large particles can be generated early in that wear cycle. So having a tool like the FerroQ really helps to pick that up, but it will not be directly correlated to ICP or direct reading ferrography because of those differences in particle sizes. Was that it, or were there other questions?
That is all the questions right now. Does anyone else have any questions?
Well, great. I'd like to thank Remi for joining us today. It's been exciting to work with your company, develop this technology, and I look forward to sharing this more with folks in the future and really seeing the first one of these units go out to somebody that has that Poseidon Live system and see that integration of data. I think that's really exciting. So, hey, thanks for joining us, and we'll continue to work with you going forward.
Yep. Thank you, Rich. Appreciate it.
Great. And Marissa, next week, what do we have on the schedule for Grease Thief Thursdays?
Next week, we have an exciting presentation of motor-operated valves, or MOVs, and we will be demonstrating that in lab today and working with a motor-operated valve. So that will be exciting.
Great for the folks in the nuclear power industry and petrochemical facilities who use a lot of those motor-operated valves. So I look forward to that. We'll see folks then. Thanks for joining us today.